This is the last video with the floor framing that I'm going to talk about. In previous videos, we went over from footers all the way up to subfloor. We talked about all the components, what they are, what they do, how the basics of how to install them. Now, this video focuses on how do we know how much material we need for the subfloor? How much material do we need for the header joists and rim joists? How much material do we need for the girders? So we're going to do some basic math to insert formulas to figure all that stuff out. So for this, you're going to need a piece of paper, you need something to write with, and do not worry about copying down this stuff here. I will give you a sheet that has all the formulas on test days. So just don't worry about this. What I want you to copy down is the name of the component and the math associated with that. So get yourself ready. Let's get started. For sill plates, the step number one is determine the perimeter of the building. Think back to your other math classes. Perimeter is what is the border when you add it all together. No multiplying, no dividing, no subtracting, just adding. Add the border dimensions. Okay? So we have a 20-foot wide by 50-foot long building. So 20 plus 50 right there. But what about these two other sides? Well, if this one is listed at 50 and you have all right angles, that's going to be 50 feet. And this one over here is going to be 20 feet. Unless it's noted otherwise in the plan, then you follow what's on the plan. But so 20, 50, 20, 50. So I said that out of order, but 20 plus 20 plus 50 plus 50, do all that, what do you get? 140 linear feet. So if you were to stack all these end to end, that's what linear feet is. Because you know, linear footage. Stacking end to end to end, what does it come out to? 140 feet is what you're going to need. Now, step two is divide the perimeter by the length of the board that you're going to use. Now, in most cases, when you're doing sill plate, you want the longest board you can, which is 16 feet. Okay? Now, granted, if you're doing a small thing, let's say a 12 by 12 addition on your house, you don't get 16-foot boards, you get 12-foot boards because it just makes more sense. You can do less waste. But anything over 16 feet, you get 16-foot boards. All right, so we're going to take the 140, divide that by 16, and when you punch it in the calculator, 8.75. Okay, so 8.75 boards, that's what we need. Now, are you going to go to the store in order to say, hey, can I have 8.75 16-foot sill plates? They're going to look at you very strange. They'll say, oh, we'll sell you 9. So round up to have whole boards. Now, regardless of what any teacher in math has ever taught you, ever, all the way back down to when you were just counting your fingers, right? They probably didn't teach you that decimals on it. But they always say, if it's 0.4 or below, what do? Round down, right? In this case, forget that. If you are estimating materials, round up. Up. I hope I have stressed this enough. Never round down when you're estimating materials, because then you're not going to have enough materials. Never round down. Always round up. Even if it's 8.02, round up. Always up when your materials. If you're doing normal math, round down some. But estimate materials, round up. So our 8.75 becomes 9. I would have to order 9 boards to make this work. Okay? So this is what I want you to copy down. Just this stretch over here. Here, there. Just have it fairly clearly and logically on your board. So step 1, step 2, step 3, so on and so forth. Okay? Give you a second to get this down, and then if you need to pause the video, you can pause the video, but I'm going to kind of keep rolling. Try to get this done in the next little bit here. All right, here we go. Next, we're looking at girders. Okay, so girders And again, we're going to use linear footage. First step, determine the length of the building. So we have 20 feet wide, 50 feet long. In our girder, represented by this purple line right here, this is where it's going to go. Okay? So we need a 50-foot long piece. So that's step one. Step two, divide the building length by the length of the board, which we got 50 feet, divide by 16, because we're going to use 16-foot boards for our built-up girders. Yeah, and these are going to be built-up girders. That's what I'm talking about right now. We're talking about LVLs here in a minute. But for built-up girders, 16-foot boards. So 50 divided by 16, 3.125. Now, hold off on rounding just yet. Okay, so we got step one, step two done. Step three, you actually have a couple of variances. In most cases, if you're doing a built-up girder, you're going to multiply by 3 because you're going to have 3 boards sandwiched together to help make that girder. Now, some cases 2 is sufficient, some cases 4 is necessary. It just depends on what the situation is and what you're using for how you use the supports. So this is where checking those span charts and span tables, there's one for girders as well. So you want to make sure that you know the code. Okay. So, but again, in most cases, multiply this number by 3 if you're doing built-up girders. So 3.125 times 3 is going to be 9.375. And 9.375 is what we would need for built-up girders. Now, if we're doing LVLs, remember the LVL is that stacked thick plywood that's cut into different size beam dimensions. Okay, in that case, most of those you need 2. Occasionally, you're going to need 3 if you're trying to have a real long opening, but most time 2 is what is required. So you're going to multiply that by 2 for LVL girders. Now, also LVL girders, it might be a you can get those 20, 25 feet long. So that's going to also change the thing here. But in that case, your 16-foot here, if you're doing a 25-foot girder or 25-foot LVL, you would, instead of multiplying or dividing by 16, you would divide by the length of your girder. Okay, but you'll multiply that by 2 for LVL girders. All right, but anyhow, we're still focusing on built-up girders here. So I did that, multiplied by 3, 9.375, round up to have whole boards. So we would need 10 16-foot boards for this one girder. Now, consulting your plans, you're not always going to have one girder. So right here, where it says a little asterisk, multiple girders may be needed. Consult your plan. So if you know you need 3 girders, order 30 boards. If you need 5 girders, order 50. So that way you can have plenty of what you need. Okay? Got this step? Again, just this right here. That's all I want you to copy down. All right. Okay, next one here is header joists. Now, header joists, if you remember, we talked about header joists and rim joists at the same time. Header joists run here, rim joists run here. Don't worry about the rim joists. We're just focusing on these 2 header joists here. Number 1, determine the length of the building. It is 50 feet. All right. 2, add up all the building length dimensions. Now, when I say this, I'm talking about you take this 50 feet here, you add it to that 50 feet. Now, let's say your building has a bump out over here, and it goes another 10 feet this way. Well, then you've got to add this one and this one into that too. So here's another 10, there's another 10 there. So then you would add that to that. But if it's just a rectangle, you add 50 plus 50. What's that equal, guys? Y'all crack it up. Now, I can almost hear you through the camera. Equals 100. All right. Step number 3, divide the building length by the length of the board. Linear footage by length of the board. So 100 divided by 16. Oh Lord, that is going to be like 5 point something. 6.25. 6.25. Right? So 6.25, round up to have whole boards. So this becomes 7. So we would need 7 pieces of header joist. We'll have a little bit of extras, and that's a good thing. So 7 pieces. All right, y'all got that? Good, let's keep rolling. Floor and ceiling joists. Now, when I say floor and ceiling joists, what we're focusing on is floor joists, but this is the exact same process if you're doing ceiling joists. So figure out how many pieces you need for the floors. It's the same thing for the ceiling. So, step number 1, determine the linear length and width of the building. No adding, no subtracting, just find out what they are. Okay, 20 feet and 50 feet, because those are going to be important at later steps. Just know what they are. Step number 2, now this comes into play. Are you running 16 inches on center or are you running 24 inches on center? Because you're going to need to do different math formula for each one. For right now, let's focus on the 16 inches on center. 16 inch on center spacing, that is equivalent to placing one joist every 1.33 feet, because that's what you compare 12 inches to 16 inches. It's 16 inches, 1.33 feet. Right? So you'll take your length of the building divided by 1.33. Okay? From memory, I think this is like 37.6. And it might have other things. 37.6. Right? Now, let's take a look at 24 inch on spacing. If you're running with 24 inches on spacing, that's 1 foot every 2 feet. So you take length divided by 2. 50 divided by 2. 25. So that's pretty easy, right? But it's not always going to be this cut and dry. I'm just making it simple just so that y'all can get the formulas in the process. All right. Step number 3. Again, this is one of those where you have to look at the plans because multiple joists may be needed, okay, to span the width of the building. So remember I said you got to figure out what the width is. So if the width is 20 feet long, and remember, if we're using dimensional, like 2x10 joists or 2x12 joists, the most we can get those is 16 feet. So a 16-foot joist is not going to stretch the entire way. So we're going to need 2 sets of joists. In some cases, you're going to need 3, 4, or 5 sets of joists to make it across the building. Just depends on what you're working with. In our case, we're going to have 1 set of joists running this way, just like this. Then we're going to have another set of joists running down this way, like so. So you're going to have 2 sets of joists. So when you have multiple sets of joists, then you come back and you multiply by however many sets of joists you need. So up here, 37.6 times 2. 37.6 times 2 equals 75.2 joists. Well, 25 times 2, that's pretty simple here, equals 50. Right? Now that we have those 2 numbers, last step in the process is round up to have whole boards. So we don't need to round anything with the 24 inches on center, but we do need to round this to 76. Now, take a look at the difference in those 2 totals, right? If you're running 16 inches on center, you're going to need 26 more boards. Now, in today's market, when I'm filming this, a 2x6 by 8 is $10, and you would order 10-foot boards for this, or even 12s to have. If you're doing the passing, you would order 12 so that they're long enough so they can have that passing and overlapping section. So let's just say a 2x6 12-foot board. If an 8-foot is $10, a 12-foot one, you got to figure it's at least $15. It might be even more than that. So $15 and you're you're buying 25 more of them, then, what is that, 25 times 15? No, 26 times 15. It's just, it's a little offshoot here, 26 times 15. Almost $400 is what you're spending to get those joists closer together. So think about that as you are working with your materials and you're planning out your structure. Are you going to run 24s? Are you going to run 16s? Now, granted, the 16s are closer, so that the floor is able to support more weight. You won't have to have as many girders. If you space your boards farther out, you might have to add a second line of girders. It just kind of depends on what's going on with the floor. Anyhow, here's your math. Determine the length and the width of the building. Divide the length by your layout, where it's 1.33 for 2. Multiply, and this is not always the case, but most of the time you're going to multiply by however many sets of joists you're going to need, and then round up. But also keep in mind, trusses or TJI joists can go 30 or 40 feet. So if you have a 20-foot section here, and you get TJI joists, you would just need one set. So you would, if you wanted them 16 inches on center, 50 divided by 1.33, 37.6. And the fact that you don't need multiple sets, you'd round up, you need 38. That's it. So it's also saves a whole lot of time, not just in materials costs, but saves time in labor. All right, you should have that by now. Okay, 2 more things. 2 more to go. All right, blocking is next. Number 1, determine the length of the building. And this one's very similar to girders. Determine the length of the building. We got 50 feet long, right? Divide the building length by the length of the board, which is 16 feet. Again, 3.125. That's supposed to be a 5. Let me go back. Page. There we go. All right, 3.125. Multiply that by the number of rows of blocking required. Remember, I talked about, they can be no more than 8 feet apart from each other. So in purple here, I've got 2 lines set up for girders. So this from here to there has to be an 8-foot max. So if we just had a 20-foot span, we could put one down the middle, it would be beyond 8 feet. So we have to have 2. So 3.125 times 2, because we're going to multiply by the number of rows blocking required, is going to be 6.25, and then round up to have whole boards, 7 total. Okay, so that is blocking in a nutshell. Now, cross bridging, when you have both the boards, they're running diagonals. It's similar to this, but you're going to have to add a lot extra, and again, multiply by 2 because it's not just one board going across, but it's 2. So again, this is specifically for solid blocking, but you can tailor this to figure out cross bridging if that's what you need there. Okay, have that. Again, if I'm moving too fast, you guys always pause the video. I'm trying to get this done before somebody else interrupts me. You should see some of these outtakes. Talk about that. Anyhow, using square footage to estimate the subfloor. Okay, so this is the last step we've got here. Number 1, determine the total square footage of the building. When I say total square footage or square footage, guys, there is a geometry term that means the same thing, it's just a different word. Write this down here. So square footage. Square footage equals area. Okay? How much area does this building take up? That's what square footage is. So square footage, and if you can remember square footage area, same thing, give or take. Apples to apples here. An area. You guys remember the formula for area? Think back to your geometry classes. Can you hear it? Yeah, length times width. Why did I put an X? That's weird. Length times width. There's not supposed to be a little X All right, so area equals length times width. Not gonna write that down. If it helps you, you don't have to. All right, determine total square footage of the building. So length times width, 20 by 50, that's 1,000. Right? Now, divide this TSF, total square footage, by the square footage of the plywood, or OSB, or whatever your flooring material is. In most cases these days, it's going to be 4 foot by 8 foot tongue and groove OSB. That's what most people are going to use. Occasionally you're going to see something bigger or smaller. Sometimes you're going to run boards. It just depends on what you're using. So 4 foot by 8 foot OSB. We got to figure out the square footage of that. 4 times 8 equals 32. So divide the TSF by square footage of plywood. 1,000 divided by 32. Divided by 32 equals. That is 31.25. 31.25. Okay. And then again, round up to have whole sheets. So 32 pieces. 32 pieces. Like that. All right, so what this does right here, these formulas, almost any project you do, you can use these, and this will get you right, your materials. Now, notice how I'm only rounding up to the next whole board. This is just for ease on your sake, to make it a little bit easier for you to grasp these and to get the right steps in the right places. I'm not asking you to add extras. However, in the world of construction, if you mathematically need 32 pieces, never order just 32 pieces. Common practice is to add 10% or even 15% sometimes. If your workers have a propensity to measure wrong, cut things wrong, and they burn a lot of pieces, well, it's a burn, but they waste a lot of pieces because they're cutting them wrong, then you might need to add 15%. But if you add 10%, that's going to cover if your workers cut things wrong, or if you cut things wrong, measure and cut wrong, or if things are damaged in shipping, or your board is really twisted when you go to, like, buy it from the store, and when you get ready to build it, it's super twisted, and you can't really use it for what you want to. Always have some extras, because you don't want to be going back and forth. The more time you are not building, the more time, the more money you're losing, and obviously the more materials you're buying, and the more trips you're taking, the more money you're losing. So adding in 10%, there's several ways to do this. Some people will say, okay, multiply 32 times 10%, which would be 3.2, then add that back to 32. That's a couple of steps. The best way to do this is take 32, or whatever your number is, if you want to add 10%, multiply it by 1.1. Okay? If you multiply it by 1.1, what that does is that finds your 10% and adds it back into your total in one step. So it's really easy. So this would come out to 35.2 pieces. Now, still, same rules apply. You want to round up. Now, if this is your 10% and you come out to like 35.02, maybe just order 35 pieces. But if it's anything more than a tenth, go ahead and just round up just to make sure you have it. It's always nicer to have it and not need it than need it and not have it. So really, for that 1,000 square foot structure, if you ordered 36 subfloor panels, you are golden. That way, if some of them, the edges are all beat up and you can't use them, or when they forklifted it up, maybe they speared the bottom piece and it's all cracked and shipped and damaged in shipping and stuff like that. That extra 10% will give you more than you need and make sure that. So you would find each of these and add 10% to all these. So 8 boards instead of 7, and like 55 boards here instead of 50, so on and so forth. So each step in this process, each of these, you would add 10%. And what that does, again, just make sure that you have enough, that you're good. All right, we have got all these done. Again, if you have all the math copied for each one of these setups here, then you are all set. Everything's good, everything's done. Take a photo of it, submit it on Canvas. Okay? All right. That wraps up all my online training for floor systems, at least the videos that I'm going to do. And we're going to take this information, we're going to continue to work with those building floor frames in class. All right, see you next class.